Okay, so as I said earlier, the first video was already getting very long, and I had to just stop it so it doesn't become stressful watching it at a go. So you could take it one after the other. Okay, still on sensors. We're talking about sensors. So let me pull up my screen and do a very quick Google search. There's something I want to show to you. So okay, currently this is my screen. Okay, so now this is the diagram of the human ear. Okay, now pay attention to this. Now you have your pinna, your syrup, anvil, hammer, your eardrums, and all of that. Now everything your ear does ends up coming from this way, your auditory nerves. Now these nerves takes in electrical signals to the brain. This is the nervous system basically takes in electrical signals. Okay, going over to the eyes, you can see the same thing which I said earlier. What exits from this whole system, from this wonderful sensor of your eye, is the word optic nerves. Okay, now scientists have been able to substitute the eye for with the camera of a person, then connect it to the optic nerves. They've been able to do that at some point. I was listening to a research that spoke about it. Okay, I'm not going to go into much details about it. Okay, that would lead us into what we talk when we start talking about sensory addition and sensory substitution. But expanding the human votes and all of that. But I think we'll talk about that on a much later base in the community. Okay, so I think I would stop sharing my screen right now. Let's go back to the slide. Okay, now we said the sensors are capable are considered as input devices. They allow the robot to have a perception of the environment, making it capable to interact with what the real world on its own. Okay. Now, this is an analysis analyzing humans, robots, different sensors, the different things we senses from the environment, how we sense sight, sound, smell, touch, distance, temperature, color, humidity, and a whole lot more. Um, okay, then analyzing them with humans and robots. Okay, for you can see it here. For sight, we make use of our eyes. Robot makes use of cameras. For sound, we make use of our ears. Robot makes use of condenser mic. For smell, we make use of our nose. We make use of gas sensors. For skin, for touch, we use our skin to feel touch. Yeah, for robot, we have what we call haptic sensors and the whole haptic systems that allow us to that allow robots to get the feeling of touch. Okay, it's also been applied in virtual reality too. Okay, it's also been applied in virtual reality. For distance, okay, how do we gauge distance? We gauge distance using our eyes. Our eyes and our brain helps us to create a perception of distance. However, for robots, yes, you could do the same with the cameras. But another thing, they are more accurate when it comes to setting the or distance because they have other sensors they use. We have proximity sensors, ultrasonic sensors, lidars, and a whole lot more. They have whole lot of system that they use to detect distance. Now we have for temperature. For temperature, we make use of our skin. For robots and all these devices, they make use of. We have different type of temperature sensors. We have DHT. The DHT. We have the thermistor, and a whole lot more. Now, for colors, we use our eyes to detect colors, yes. For robots, they have color sensors, they have cameras. For humidity and wetness of the environment, we use our skin. It tells us how moist the environment is. Okay. For robots, they have the same DHT. It also measures humidity and temperature. We have soil moisture sensor, we have water sensor, and a whole lot of that. Okay. So, going over to the next, we've talked about sensors as a fundamental building block of a robot. The next thing we're going to be talking about is actuators. Okay, now please pay attention to this. Okay, now actuators allow robots to take action based on the changes detected from the environment. Okay, now when a robot detects a sound or someone standing in front of it, it has to respond to it, just like we respond to our surroundings. The actuators allow the robots to carry out these responses. Okay, you can think of actuators as output devices. Okay, but more emotion related. Okay, um, where just where we see sensors are input devices, actuators are more of output devices, but they are more related to motion. When it comes to motion, yes. Okay. A good definition of an actuator is a device that causes motion. It can cause linear motion or rotary motion. Or so whenever we mention motion, we mention actuators. We are looking at motors basically. Okay. Now remember we said it can be linear or rotary. Okay. We have linear actuators that allow you to move just in one direction, left or right or up and down, just one way. You'll have rotary movement. Okay. Now let's say we're building a robot. Go back to the delivery robot. Okay. Let me go back to one of the slides. Let's say we want to build this robot for the restaurant. Okay. Now when the sensor senses the environment, sense okay, there's something in front of it, or the area is free. It will send the signal to the brain. We're already going further. When the brain has to send a message toward the actuator in this case is the electric motor. The electric motor is what causes the rotation of the wheels. That is the actuator. It's what causes the motion of the wheel. That's the actuator. Okay. Now let's say we want it to grab, like over to the next one where we saw a kitchen, a robot chef. Let's say we want it to grab, pick up something, a knife or something. It will have to control. The arms will have to move. Now, those arms have electric motors suited into them. They could be servos, they could be brushless, they could be stepper. We'll talk about the different types of motors as we move forward. Now, those motors are what we call actuators. As long as there has to be motion in the robot, there have to be what actuators. Okay. Now, you might decide to use electric motors or pneumatic actuators. More on that in the future. Okay. So now, okay. Sorry about that. Now, okay, we talk about actuators, we talk about effectors and manipulators. Now, I deliberately brought this next because sometimes it can be very confusing. Okay, now they carry out the end result of the actuator. An effector is any device that affects the environment. They are known as end effectors. Now, effectors could include legs, wheels, arms, fingers, wings, and fins. Now, the term effectors and actuators are often used interchangeably. I said this earlier. Okay. Now, let me explain the difference. Okay. Now, let's say we go back to the robot chef. Now, we wanted to pick up a knife. Definitely, it will have an arm or a means to pick up the knife. Now, one of the things is this is for you to pick up the knife, there has to be movement. The arms have to move. Now, those for the arm to move and grip the knife, there are actuators that causes it to move. The arms is being controlled by electric motors. If you want to build a robotic arm, you have to use an electric motor. Okay, I'll bring up an image of that. When one start working, I'll bring up an image of it. You see it. For the arm to move, for the arm to grab, maybe grab a phone, grab a knife to cut, or grab a pot or a pan, there has to be motion. You understand? There has to be motion, and this motion is carried out by what electric motors. Now, the electric motor that causes the motion is the actuator. The arm that grabs is the effector or the end effector. If I hope I've done my I've simplified it enough. If not, you can still uh send a direct message or drop it in the comment below for more questions. Okay. Now, a robot manipulator is an electrically controlled mechanism consisting of multiple segments. Yes. Okay. They perform tasks by interacting with the environment. Okay. Most times when we talk about manipulators, most time we refer to robot arms. Like we have Kuka robotics arm, we have this one over here. When we talk about manipulators, 70% to 90% of the time, if not 100% of the time, we're referring to what? To robotic arms that are used for manufacturing and a whole lot of that. Okay, but please get the difference between actuators, manipulators, effectors. The effector is what carries out the end result. Remember, we said actuators are like output devices. Okay, now going over to the delivery robot, I want you to see this. Okay, we said now it's time for the vehicle to move. It has received the package, move over to the destination site. Okay, it's definitely we'll talk about when we start building one. We'll talk about communication. Or let's say it has to you equip it with a GPS so it know the location is going towards. Yes. So let's say we're working on the FedEx. We want to replicate the FedEx robot. Replicating the FedEx robot now, it will have to have a GPS to sense its location, to better sense its location and manage its location, okay, and know where it's going to, okay. Then, when there's nothing in front of it, when it's time to go, it would have to move. For the robot to move, there have to be actuators known as electric motors. And as I said earlier, there could be different types, okay. Now, there have to be actuators that can control the robot. Now, the actuators can control the robot the robots have. Okay. Now we have some. Please let's take note of this, please. There's some robots that are stationary; they don't move up from one position to another, but they still have a lot of motion within the axis. Okay, we'll talk about. Subsequently, I would talk about that. When we talk about the work zone and a whole lot of that, safe zone, a whole lot of that. Well, I'm trying to make this as precise as possible so you get started with everything you need to know to building your next robot. Now, when we talk about locomotion, not all robots are bipedal. Remember, we said this when we're talking about some myths people have when talking about robots. It doesn't have to exist in two legs. It could be existing in a wheel. It could be four wheels, five wheels. It could be even extraport, more than two legs, four legs, six legs, and a whole lot of that. Okay, power source. No robots exist without a power source. Your sensors have to be powered. Your actuators have to be powered. The brain of the robot has to be powered. So power source is a fundamental part of a robot. You can decide to use solar system to power your robot. You could decide to use batteries. You could decide to use a whole lot more. The essential thing is this: there has to be a power source. Okay, okay. So over to the next one, which is the brain. Now, this is the control center. It reads the data from the sensors, interprets it, and then tells the other parts of the robot what to do and at what time. Okay, over to this one more time. Now, this is the powerhouse of the robot. The same way I showed you the image of your eyes and your ears that takes the signal, sends it to the either auditory nerve or the optic nerve to the brain, and your brain, your human brain interprets this information, then tells your body to move or stay calm or run. Let's say you're in a public place and you hear a gunshot being fired. Your ear, once your brain interprets that, it tells you it's danger, start running. Okay, and Nigerian slang, we start hearing, you hear time to jackpa. Okay, for those of you who can relate a whole lot of it to it. So, so also the robots, their brain takes this sensor information from these various sensors which we've listed, and what interprets it and sends it to what to you to the other parts of the robot. Okay, we could, let's say the robot is already in motion. We're analyzing the feathers. Let's say the robot is already in motion. The robot is already in motion, and someone runs in front of it. Okay, now remember we have sensors. The camera could pick it up that okay, there's something in front of it, there's an obstacle in front of the robot. Immediately the camera picks it up, it will send a message to the brain. The brain of a robot is a microcontroller or a microprocessor. That is what we use as the brain of a robot. The camera will pick the message, send it to the brain. The brain will say, okay, there's something in front of it that shouldn't be there. Then send the message to the actuators, which is the motor, to stop rotating, to either stop rotating, stop moving, slow down, or reverse. While the motor does these three things, any of these three things, the wheels will have to respond. Now, when the wheels stop rotating, the whole robot will be at a standstill. If it slows, when the motor slows down, the acceleration of the robot will reduce. If the motor spins backward, the vehicle would go backward. Okay. If the robot decides to reduce the speed of one side of the wheel, okay, it would what? It would reduce it. It would increase the speed of the other side. It would cause it to turn. I'll show you a simulation on that as we move forward. Okay. So simulation and robot environment. This is very important when we're building robotics. Okay. For some of you who might not have enough equipment, enough tools, and a whole lot of that to start building, because as much as robotics, it's sweet, you require hardware. Remember, you said it has to exist in the real world. So one of the things that help us to build, and one of the things that could help you to start building your robot immediately, it's understanding simulations and simulated environment. They allow you to design a space as though it's in the real world, add the environmental change, environmental variables, temperature, a whole lot of things, and build a robot within that virtual space so that it becomes easy for you to bring it in real life. You could see some of the, you could analyze a lot of things that are happening before you bring it into the real world. Okay, so now I want us to analyze a robot. Let me share my screen right now and pick up a robot. Okay, let me share my screen right now. Let's pick up a robot. Okay, going back to the slide. Before I do that, before we do that, I want you to look at this with everything I told you about the anatomy of a robot. I want you to do this. I would like you to do these tasks because it would help us a whole lot. I would like you to do these tasks before I upload the next video. Or before you start watching the next video, because I'm going to be uploading all of them at once. I want you to look at this FedEx delivery robot. This FedEx delivery robot, which is okay, it's known as the same day delivery robot. Yes, and this other one used in a restaurant. Using the anatomy I just gave to you, draft out a block, try and see if you can draft out a block diagram of how this robot works. Okay, you know it has to have sensors that will communicate towards the brain and all of that. Try and list out the sensors. Okay, it needs a sensor to sense this, to sense the environment, to sense someone in front of it. Draft out like a map of what the robot is going to contain, how you want to, the kind of power source you want to use. You might want to use, I'm already going detailed into the assignment. You might want to use batteries, you might want to use solar. So I want you to draft out your own thought on how you would build this robot using what you just learned right now. Before we start going forward, we're going to do the same tasks now. We're going to analyze 2 to 3 robots. We're going to do the same tasks right now. But I want you to work on it first of all before you pick up the next video. Please send it to me. I'm not going to flog you or punish you if you don't do it, but it's really important that you get to do it. So by the time we start going up the next 2 phases, it's going to be much more easier for you to comprehend and understand exactly what we're talking about here. So at this point, I'll be signing out of this video. Thank you very much. Thank you very much.